Yes, Sudhir.
Yeah, okay. Okay, good morning, everyone. So today I'm going to talk about two topics, and one is about the serverless movement. So when where the term serverless is is a little confusing, and I basically wanted to shed some light on what is behind it, and how do we how are they being implemented in a very nice way in the cloud environment. And so that is a little tech heavier topic, and I hope I can take it in a lighter way, and and give you some give some like information that is useful to you, all of you. And second is the no code apps. This is something which came to my attention a few weeks back, and like I attended a like a webinar, and and it was interesting to know that like that market is so huge. I never knew that such a thing existed. So I'm going to talk on those two topics, and hopefully they are interesting to the whole crowd. So let's I'll take up the serverless first, then I will go to the lighter no code second. So when we talk about serverless, what it actually means, there are serverless, like there is no server, but that is not true. Actually, what it really means is, it means you don't have to worry about the server. It is being managed by some other. Typically, this is being applicable to the cloud environment. So in the cloud, the compute is a big part of the cloud. Where like typically what we have is we had the servers, and like then came the different. I'll talk about that later. How the evolution happened. And when we talk about overall about serverless, it means like your computing requirements are you don't have to worry about that. You can worry about mainly your application code, and you can go ahead with your business logic. So in that part, and second thing about serverless, advantage of serverless, you are it's a pay as you go model. Means you whatever you use, you pay only for that. Otherwise, you are not paying for anything for the computing part. So that is a very good advantage in terms of go to the market strategy and those kind of things. So let's get into some of the details, like how this whole thing evolved from time to time. So this is a good old time, like we had a physical servers. Every company had a server room, and like a cold AC room, and there were like lots of servers with the hissing noises, and and everybody was happy. Like this is like maybe 20 years back. So and there were a lot of people, networking people, who talks only like in terms of IPs, like subnet and stuff like that, and like, and then things were going fine. But then I think the problem came when people wanted to have more scalability. Like you have, okay, you have these many servers, okay, some in case of like as the web technology caught up more, like the business wanted more scalability, like on demand scalability and all, which was really hard for the like a physical server setup. And also the other factor was you buy so many servers, and if your utilization is really low, then that is costing the company. And think about if you want to start a company, and physical buying the server was a big budget of the company. So then the next evolution was virtual machines. Virtual machine is something like this on the first image on the left side. I hope it is visible to all of you. So the technology behind virtual machine is you have got a very powerful machine behind hardware, and top of it you have got a host operating system, and on top of it there's a layer called hypervisor. That is a layer that helps to run multiple virtual machines on top of this big computing piece. So the advantage of virtual machine is that you can have multiple virtual machines can have their own OS, And so you can run multiple OSs parallel, and you can, it's a pretty much, it provides a very good scalability, like, and in terms, we can launch a new server in a time frame of a few minutes. That was really good. That time it was really a big thing. And so slowly, like, all the deployments in an environment, they moved onto virtual machines. So slowly, like a physical servers, gave way to the virtual machines. But they had the issue that it is obviously, when you needed scalability, it is not coming up faster way. And second thing is, like, they had problem, like, what happens if you are a big computing power, what happens if that goes bad, or it's then what happens is all the virtual machines running on top, they also like go for a toss. So then we needed something that is more like agile, and more fastly scalable. So then came the container technology. So the on the second figure, that is talking about container technology. So here you can see you have an operating system, and there is something called container like platform. There's a container orchestrator, and top of it, you are running the containers. So the advantage of container is that it's self-contained. So the biggest advantage is, if you are deploying an application, the runtime, you need a runtime for that, and you need some application code, and you need some other dependencies. So a container packs everything nicely into one package, and then then you can run it on top of it, and it is very fast. It is very lightweight, and it is very fast also. Like, you can in a few seconds you can launch a new container. So that was very attractive. And like, but container technology came actually like in 2000, I think 13 only. It's pretty new compared to like a evolution that we had in the last 10 years. So then after that, so we wanted, cloud came actually after the container, like, after, like, by that time, cloud became very powerful, like a medium. And then came the like, functions are nothing but, on top of the containers, you are they are the you are running the functionality. Say, for example, like in cloud, in AWS, if you take something called AWS Lambda. So what you are doing is you are writing a function, and that function can be executed independently. It's like, you are invoking an application that behind the scene, you call that function, and you pay only for the execution time of that function. So that one is like, because that's really good, and because in the sense, you don't have to worry about containers, and you are providing a service that is running on top of the containers, and you worry about writing code for that function. And rest all, and you don't need an initial investment. This cloud is taking care of running this setup, and you only have to write the function. So that became very attractive, but it had limitations, because in the functions, like in AWS or Azure, had limitations, like, how much the image that you upload has a limitation, and functions can execute only for this many minutes. And so to overcome that, like, recently the cloud, their vendors have come with a technology called function as a container. Basically what it does is, instead of running a function, they launch a full-fledged container for the function. So that way, you don't have limitations of size, you don't have limitation of time, you don't have limitation of like a like how you can execute, scale whatever way you want. So that is where we are, like, in the currently. And so when we talk about so I want to talk about why I'm talking about the the basically what we want, what problem we want to solve is, we wanted to solve the problem of scaling. That is where we wanted a strategy, and that is how the thing evolved. Okay, so when you talk about scaling, I want to show you, like, how the scaling map currently mapped to a cloud environment. And I'll show you a sample application, how this behind the scene, how they are doing it, without you knowing about all these details that I'm going to talk about. So a little background about how the how are we implementing scaling using the Dockers, and like the basically the container technology. So the container technology, as I told, it came pretty new in 2013. It was released, and the main advantage was, container was, as I spoke before, it was a lightweight, and and it was isolated. Like even if while running the application, one container crashes, you can very fast you can launch another one. It was, and crashing of one like instance doesn't cause any harm to the other one because they are isolated. And and then but the container as such cannot bring a lot of all these things, what the crashing, and bring another one instance back, and like memory management. It needed a lot of the runtime needed a lot of like a orchestration. And there came a softwares like Kubernetes. So Kubernetes is an orchestration engine. So where it manages the containers, things like like you have an application with a specific version, and you release a new version, then it has to eventually change the environment all into a new version. And if at the runtime you have to manage memory, lot of complex things are happening in the environment. So the orchestrators, they are the real engine behind the scaling of the like scaling technology. So Kubernetes is like open source technology from Google, and it is very popular. And it is the most important player in the container technologies. But but there are alternatives, like like Docker itself came with their own technology called Docker Swarm, and then there are like a lot of Apache things, like like alternatives like Mesos and all. But then you'd ask, why, if Kubernetes is so good, why do we need alternatives? So mainly because Kubernetes it's really it's got a very huge learning curve. It is complex. So and so implementing that as alone and for a company will take a lot of resources, a lot of expertise it needs. That is where like the cloud technologies, they come with technologies to like wrap around their own services in that internally uses Kubernetes. And I will talk about it in the coming. So these are the alternatives we have. Like if these can be used independently also, like Docker Swarm and all. We don't have to have cloud. You can have your own like a container system in place. So then I'll talk about the cloud adaptations of how they use the. They have some of them, most of them have their own way of implementing Docker, and they also, some of them have like a wrap around the Kubernetes also. So like I want to just wrap up the whatever I told before with the picture, like it'll be easier. So this is how the like the whole scaling thing works behind. So reverse proxy is nothing but a load balancer. Think that you are like you think about Netflix. Like it has got millions of users worldwide, and and at the time like millions of people might be watching. So the basically load balancer, what it does is it basically it launches the application in a few in a few servers. And as it as the demand increases, it scales them horizontally. This is called horizontal scaling, where it adds more and more servers, and they take the request, and the load balancer takes care of pushing the request to the respective one. And then has the component called registry. So this is part of the container technology. It's called a container registry, where it does where we talked about we have an application where we package the application. So initially it was version 1.0.5, and we deployed to all the servers, and then we found a need. Oh, we need to upgrade it to 1.1. Then then comes the orchestrator. So orchestrator takes care of deploying the new version to all of them. Like when it is done with a request, and at the new request it will launch in the version 1.1. So this seamlessly doing that, that is what the part orchestration play. So just wanted to explain in terms of through a picture what I talked before. And then so at any point stop me, like if anything is you don't understand, or is it too complex, or it doesn't make sense. Okay, so the other part of the serverless movement is the way change the way we are developing the applications too. This is typically applicable to the cloud technology. So so one side is we have computing, like computing is being revolutionized by not by the serverless only. Serverless is a big part of it, and there is a serverless, and other part is the managed services. So it changed the way we develop applications and we think about applications. And previously, when we think about having an application, typically web application, then we have got a front end, using whatever technology like HTML or React or Angular, and the behind, we had, the either web server, which has got or application server, where and then it, and behind we have got a very complex structure which takes care of load balancing, and we have different layers, like we have business layer, we have got database layer, all those kind of things. Now with the cloud coming, what has happened is, we have got is something like, you are building an application, like you are building a Lego, like a Lego application. Now you have got services, managed services, coming up for all the kind of requirements you need. So like for the networking, storage, monitoring, and even the technologies like machine learning and all, what they are doing is they are developing the model, and ultimately how is it being presented to the user. They come up as a service. So at the end, everything is a service. So so managed services plays a very important role in the new application development strategy. So here I want to show you, like how a typical cloud application looks like, and how the serverless plays a role in that. So this is an application sample application where the user is uploading an video, and he want to basically do some processing on the video, and he want to generate a thumbnail image, and basically he want to process the image, and generate a thumbnail, and and basically respond something back to the user. So I just want to show you that what all things are here serverless, what all things are managed, and how the application is being built. So if you take a look at this, this is the S3, or basically storage system from Amazon. So that is a managed service. You don't have to worry about your storage. You just have to create a bucket, and then give that you get a URL, and then you are free to you can programmatically, or you can through a UI wise, so you can upload images. So in this case, the users have an app, and basically they are uploading through the front end, they are uploading the image to the bucket. So and then then next is when as an image comes, it creates an event. So the other thing is what changes, the programming becomes event based. So as soon as an image comes in the bucket, then it invokes another, it's called a function. We are talking about functions, right? This is called a Lambda function in AWS. So it invokes a function, and which is a serverless function. And what the function does is, because is launching another container, so there is a service called another managed service, which is called Fargate in AWS. So what it does is, behind the scene, it is using containers. So Fargate, what it is doing is, it is wrapping the service is wrapping the container technology. So basically what it does, initially it launches, you can configure to have only one container, and as the demand increases, it launches more and more containers. So this serverless function is calling the serverless a container management system, which is Fargate. And then that does the processing, and then at the end of it, the processing puts the result back into another storage. Okay, and then it calls another Lambda, and that Lambda updates the user back to updates user accordingly, whatever you need. So what actually the developer does in this? There's a the different in the way we think about development is. Here, what the developer does is, there is a developer who is typically the DevOps, or even the developer who has to create the infrastructure. There has to be networking, there has to be storage, there has to be to configure this Fargate, to configure other infrastructure. So there is there are technologies where you can write the infrastructure as a code. So there is so that's what typically happens first, and then you need to code for this serverless function. In this case, it is a very simple technology. Whenever event comes, basically redirect it back to the back to the image processing, like a container. So this is where the developer writes the core logic, and so developer actually writes only this Lambda and this one, and rest of it is part of the infrastructure. So these are different blocks. You just have to combine them, and there are a lot other services, like around 200 plus managed services, for emailing, for all kinds of services. Now it is done through managed services. So the way we have been developing applications is changed in a huge way through the use of cloud technologies, and serverless plays a very big role in that. It's a very scalable technology, and it has played a very big role in developing launching startups and all those kind of ecosystems in a much faster way.
So, quick question, Sudhir.
Yeah.
Hi, this is Nisha here.
Sure.
So, uh, again, I'm not techie, so I'll ask very basic questions.
No problem.
The containers, what role are they playing apart from your, for example, your space management? So, if I am company X who needs space on cloud, the containers are telling me how much space I am buying. Because at the end of the day, it is all moving into, like, if you use via the graphics that you shown, end of the day, it's all merging into a similar bucket. So, what role is the container playing apart from capacity management for the client?
Container is playing a role. Container is part of the computing. Okay, so
Okay.
when you had some logic, that process the image or video, right? That is
Mhm.
being encapsulated, inside, basically deployed through the container. Okay, so you send a request, with the whatever, you basically you store the video here, and you send a
Okay.
link of that video to the processing logic over here. And the managed service, what does is, initially it launches only one container. Okay, then
Okay.
suddenly the website is getting so much request, it's getting
Sure.
so many
Mhm.
requests for processing. So it as the based on some logic, it launches more and more containers. So, and it is like,
So,
you don't have to, you can set limits on what is the max and all, but it is very
mhm.
seamless. You don't have to worry about how that happens behind the scene. That's the beauty of it.
So space management is just one part of it. The other part is computing. Okay.
Space is being managed by the storage service, which is called S3. So basically, S3 is, when you talk about S3, S3 it is called it is an infinitely scalable. Like, you can store any
Mhm.
amount of data inside S3, and there are different levels. Like, as the content gets older, you can move to the lower levels, which costs you lesser. And the S3 basically manages storage, and the container is basically, it's a computing technology. And the service that manages is, basically what it does is, you don't have to worry how the container is working, how it is being scaled. You just have to
Mhm.
say through a configuration how you want it. If the utilization goes above 70%, then I want a new container to be launched. So that is the beauty of like managed services.
Okay. Thanks. Thanks, Sudhir.
Sure. So basically, I thought, this will be useful to the product managers too, because even though product managers don't have to worry about how the technology is being implemented, but it will be good for them to know that, okay, there is a way of developing the application in a serverless way. It doesn't have to be the whole application. Say, for example, like, if you want to develop some like a some job, which has to be done every day at a particular time, and then you can, instead of writing it, you can it will be good to know that you can write a simple Lambda function, and and behind the, if it is a easy function, it doesn't take much time, then it could be a Lambda only. Or if it is a complex function which needs a lot of time, then behind the scene, Lambda can be powered behind the scene by a container. So I just wanted to know that, like, when somebody talks about this terminology, you have got a better understanding. I hope that was helpful for the product management, like people over
Yeah,
there.
so I think that is really helpful. And as product managers, we do need to understand all these on a high
Yeah, at
level.
least at least the high level, how it works, how
Yeah,
how the overall
do it
picture
with
works. That will be
tips
really.
for every task, but yeah, understanding on a high level, it is important because
I
building
think
something
Also, Sudhi, to add, I'm also attending it because to understand the capabilities of what is feasible for users with the cloud. You know, I mean, it is more around how it's going to enable certain things for us, certain requirements.
Exactly. Yeah. So cloud, the thing is that, like cloud is now, it brings infinite possibilities, because you don't have to worry about so many things. A lot of things are automatically be taken care, So still, it is not, doesn't mean that, the programming has got simpler, Still you have the issue with, even though a lot of many things are taken care, still the complexity level is reduced because you don't have to implement many things on your own. But still, it is, you need like some expert hands to, like manage these things also. So, but still, it is much better than, when you look back like 5 or 10 years back. That is why there is a big movement towards the cloud transformation happening in the industry. Yeah, go ahead.
Yeah, sorry, I joined a bit late, but this is really interesting discussion going on. What I see. Thanks for such a nice session. One question I have: this is event-driven. You are telling, right? So, is there any Kafka or anything involved?
Event driven means, like what I mean by event driven is, for example, like uh, uh, like these, we have a lot of managed services, which which basically implement the logic. Say for example, you want to you are getting a request. Ultimately, you are getting a request from the user, right? And then when the request receives, like you might want to do like take an action on that, right? So previously when we think about the backend, you are thinking about, okay, you have got a server running there that is listening on a port, and then you get a request, you hand it over to another function, another library, or which takes care. Now the thing is, you have to think in terms of these managed services. Say for example, in this case, like we are user is dropping an image to the bucket, and that is an event. Like image arrived is an event, and that invokes another
Lambda function.
Lambda function. So it could be another thing, like you can have, there's another called simple notification service, like where what it does is, it does something like, say for example, you are receiving an image, and on the image, you want to do like n number of operations. So you want, say, something called fan out, like you get one thing and you want 10 people to work on that. Okay. So so you can put that image into a notification, into a like a simple notification service, and there notification service can like tell, like 10, like maybe it can spawn 10 lambdas to do 10 things. Okay. So the thing is that, you have to know idea about, like there are so many services, and then most of them, work based on, they work interconnectedly, because, one event, you can program the other service to be involved. So that is the beauty of, it's kind of, similar to Lego, right? You one Lego hand overs to the other one, right? So your building blocks are the managed services, and they are all event driven. Like most of them are event driven. Like even the Kafka or the AWS got something similar to Kinesis, they are all event driven, right? So you get an event, and then based on the event, you want people to work on, like different n number of services to work on, this one event, and so that is the whole beauty behind it.
So what I understand is, here the moment the video is getting added by the user on the left side, I mean the client side, it is actually triggering a Lambda function. And then the Lambda, on the other hand, it passes that as a task to the ECS instance, where the Kubernetes containers or this kind of EC2 containers are there.
Exactly.
And there, whatever processing or whatever is happening, and then the thumbnail goes to the user
Other
can
bucket.
see on the other
Exactly.
bucket.
Yes.
Yeah. And the event is itself not exactly pushed by Kafka or Kinesis, but this is the Lambda function itself trigger. So
Exactly.
the way we do with the server communication, it is not being like into place. So it is a push, a notification kind of thing. It happens. Even we can attach a notification.
Correct.
Got it.
So bucket has got many events, like event, like something content is deleted, content, like created, updated. You can have different events on that.
So are these EC2 or Kubernetes pods?
Okay, so there are like two. They are like, they are the pods actually. Yeah, Docker images, or Docker containers, or Kubernetes pods. Yeah, exactly.
Oh, so scaling is not a problem.
Scaling is not a problem. You don't have to worry about the scaling part. So
got it. Yeah. Yeah. Thank you.
Sure. So there are two technologies. One is, AWS has got two technologies. One is Fargate, and which is serverless way. And second, you can have like, called ECS, where, instead of the containers, you can have your own machines. Like, for example, like you can have, like similar to the virtual machines. You can behind the scene, you can have the, instead of launching the containers, you can have the machines behind it. It's called the ECS service, Elastic Container Service in AWS. And Azure has got, matching technologies similar to this.
But that is not a managed one, no? If we take the VMs, we have to manage them.
Yeah. Behind the scene, VMs you have to manage. Yeah, you need to at least, I mean, in the sense, manage in the sense, you need to say, instead of the container, if you had VM, what will happen is, like why
the responsibility is ours to do every other scaling and all those things, and we have to do the what do you say, functionality on our side.
Scaling is being taken care by the service. Instead of Fargate, if you have ECS, and you have ECS have two options. And one, ECS can have the containers, and ECS also can have machines. Okay. So if it is a machine, what happens is, you configure to have one machine initially, and as the load increases, it launches another machine. Okay. And you don't have to manage those machines. Basically they are virtual machines only. You just have to say I want this, like this much memory, I want this much computing power, and and then just like just like the container, you just only thing is that like when the cost, how the cost is being managed might be different for a container or for a ECS machine. Actually, if you are launching a machine. See, even the container behind the scene, they have, how are they running? They are running, they behind the scene, the cloud vendors, basically they are managing it through machines only, right?
Yeah. Ultimately
it is a machine only, but instead of actually launching container, you can launch the machines also. That is another possibility.
But here the Fargate, that advantage is like it is acting as a managed service or managing the clusters. So that way it is better. I mean, easier rather.
Exactly. Yeah. So you have to work on. You have to less work on. You basically what you are doing is you go something called registry, and you load your image to registry, and then point that image to the Fargate, and then create a cluster, and then that takes care of everything. Like you don't have to worry about what's happening behind the scene.
That's great. Thank you.
Sudheer, I have a quick question. So container versus virtual machine, I mean, if you have any idea, which would be more cost effective?
That depends on the whatever strategy you want to take. So we typically use machines when you have like, for example, you want got a bad job to run, and like you at a particular like job run, and you'd say heavy like, depending on, some of them are you want to run it, and then like get rid of it, those kind of scenarios, you will go for it.
Right,
and
right.
The container technology, like when you have a lot of work to do behind the scene, okay, like configuring and all those kind of things, right? And so if you want to go for a simple scenario, where then you will go for the like that's one scenario where you'll go for the machines directly. And second thing is, like there are like places where you will use let me think about it. Kind of like bad jobs, like that. Okay, I'll tell you one example, where you need hard machines, like in data warehousing, and like this one, right? So basically where you are doing the big data management, and where basically you need a lot of heavy machines only to manage that. So that is where one area I can think of, where you really, lead the machine.
So, so I mean, like, I can ask another question also, like for the containers to spin up and to bring them up. I mean, it would be like only the time they are up, we are getting charged by the cloud service, right?
what you are doing is, you are actually doing working only with the Fargate. Fargate is a service, and Fargate has got a pricing mechanism. Okay, and that pricing mechanism depends on on what how we are configuring. Like in this container, when you are creating a container, you have to say, okay, what kind of memory you want, what processing you want, and based on that, the level you choose, and you get charged.
Agree.
Yeah, so this is something which you can change also. If you find that, okay, you are is whatever 1 MB or what and is not enough, 1 GB is not enough, you can basically seamlessly you can change it, so that is one other.
So like see, if I have to say the container and the machine has a similar configuration for in my case or in general, so what I'm saying is that the machine is something I've manually kept ready, but I would keep my instance in a stop phase where I see that there is no charging happening for it, right? But then when I need it, so effectively you're saying like Fargate is going to take care, or I can put a code in where it's going to give a command to bring up and start an instance and bring it up, which is a machine set manually, or a container if I want a dynamic machine to bring up to be up. So that's the only difference, right? I mean, both the cases, containers and machine, I can keep them in a non-usable state where I'm not getting any penny charged, right? That's
Fargate is a Fargate is serverless. That means, in the sense, when you are not using it, you are not paying for anything. Okay.
Perfect.
And for the if you are using auto scaling using machines, what you need is, you have got at least one instance running, okay, and one image running, and as your demand increases, it launches more and more machines.
Right.
Okay, so how even the container behind the scene, they are running an array of machines, running behind the container technology also, right? So only thing is, like if you are, it's like if you are not using it, you are completely not paying anything for serverless that you are doing.
Yeah, clear. Thank you.
One thing I want to add on in this Azure, right? I think when we are using this AKS, if any of you are already using it, so Azure Kubernetes Service, there it is a kind of pay as you go. But in case you are taking VMs where you are actually using the VMs, so even if it is pay you go for the extra jobs, but you have to pay the rent for VM. So I mean, a kind of certain charges are there, even if you are not directly using them. So Kubernetes service becomes that way cheaper. On the other way, if they are on full volume, then AKS is actually a bit pricier. That's what I found.
Okay. That's a good point. I just have one query, Chitali. I mean, for the VMs, when you said we have to pay, but can't we control with the job? I mean, can't we control to stop and start based on...
Yeah. That is very doable. You have the dashboards, right? You can easily stop them when they are not in running. So that time your cost automatically reduces, and you can check them.
So because currently, like, we are using AWS, so we have put a job where it takes care of it's a scheduled job, different thing. But what I'm looking forward to is an event driven on and off of a VM, so that I'm absolutely charged to the point where it's required to be on. That's all. So that was because containers I know are going to be event driven. The bringing up of the containers would be purely event driven, as Sudheer has explained this flow. But in case of VMs, can available is what I was looking
actually in VMs also, there is something called auto scaling, so auto scaling, what it does is, like you have you are allocating you have to have minimum number of machine running. So you are running one machine, and when the demand comes, you can say, I want to scale up to 10 machines.
Oh, perfect.
So what happens is, if you are not using it, it will bring down it to one machine. So you are paying only for one machine. But demand comes only, it launches more machines. So so I hope, like Chaitali, whatever you told, maybe it was a scenario where you manually allocated VMs, and then it is your responsibility that you have to shut down. If it is a auto scaling, then there should be a way to it automatically takes care of scaling it. It's called.
Okay. Thanks, Chaitali. Thanks, Sudheer.
Sure. So that's about the first part. Now the second part, this is about a little lighter topic. So basically about no code or low code apps. So the like basically what people want is they want they want everything fast, like it want to happen, like everything so quickly that like even full-fledged applications, like can be developed in a few hours. Like so, I attended a like one. I'll show you the session I attended, like week before. Okay, how do you get rid of this bar? Okay, forget it. Okay. So basically, this is the app. They used something called Glide. Okay. So, and they developed this app in 30 minutes. Basically not developed, like basically we did it together. There was somebody leading and, they explained how to develop this course. So basically this is a kind of, where you have the online courses and, then you have mentors and you go to a course and, courses got lessons and duration and, and if you click on the lesson, there is something, you can mark. So it's a full-fledged, application, where, like a mobile application, and it can be launched in this day. Like made us, create the whole application in how basically in an hour. So the basically this is working behind the scene. It is behind the scene. It is only like a worksheet from Google Sheet. So this is what the data is coming from. You have got the courses here and what the description and and in a thumbnail, you can I'll show you how they manage it. You don't have to provide it here. They can through the app. You can set it, and then these are the mentors, and these are the lessons. And so you got different depending on the course, you got different lessons. So here this is the corresponding app representation of the data, and here you can configure the, for example, here you can configure the image, so you can either update it from like there are different ways. You can either upload from a Splash or something, or you can upload it from your machine, and that update the sheet behind the scene. And all the screens were developed, like pretty much, like you just drag and drop kind of thing. So but like so it looks really good and fast, and a lot of, but there are like this no code platform is not like without issues. So for example, if you take this application, for example, then let's see, it is published. It's only published. Okay, so take this. Okay, so this is now I'm watching on the web, but in order for this to be an app, what you have to do is you have to contact Glide, and they will evaluate the app, and they will tell like how much it will cost for them to publish it. And what they will do is they will give you an like a whatever deployable, like for the iOS or Android, like APK or whatever, and then that you can deploy, that you have to deploy onto the like a iOS or Android platform. Okay, so there are two things. One is you have to pay extra to the this developer, basically the whoever is no code application provider. And second, you have to like provide, there's an extra cost for deploying the no code app on the Google or iOS. So there are two costs involved, but still if you take it like the fastness you are achieving with the no code apps, it is something very very commendable, because otherwise it will take a few months for somebody to create all these kind of things, and you can do that in a few hours. And then, if you have an idea which is really, like there were some case studies they told, like because of the COVID, like basically that firm was something and somebody, they were, that's a firm who does the no-code app development. They told, in the neighborhood, there was a meat shop, which went, basically because of the COVID, they couldn't open because, and, basically they came up with a no-code app and surely there was a demand for people, so basically they could sustain their customer base, with the help of an app, and that app, they could launch in a few weeks. So that is where the power of, no code, it has got issues like, it is customization and, like all those things. But if you are looking for something which is really fast and, then no code is a good option. So there are a lot of players like, in the Glide, Bubble, and, Webflow, Airtable, and a lot of things, over there. And it is expected that it is going to be like, by 2025, it's going to be a huge market, and not as maybe as an independent, but maybe a mix of it. So when I say that, what it means is, like even the big players, like Google are betting on this, So for example, Google acquired this company called AppSheet. So it was in 2020, and AppSheet is.
I saw that last year.
Yeah, last year, yeah. So it is part of their, basically it is, Google is telling that it is part of their strategy of, having the low-code apps, as part of their. So just like that, it's not only Google, here you can create full-fledged apps, mobile apps, using no code, and, and pricing. Although I haven't tried this, but overall, it looks really, basically they are talking about, developing the enterprise apps, using the no code platform. And I'm sure, it will have, nice integration with the cloud also. And also AWS also has got, similar, mobile application thing. They call it Honeycode or something, Honeycomb. That is a no-code mobile app development platform. But I haven't seen that, very popular, but, it's still existing. People are playing around with the technology. And so there is another company called OutSystems. They are claiming that they are the enterprise level no-code app development platform, and they are internally using the service providers like AWS and Azure behind the scene. And so one challenge, the no-code development was facing was previously just like the, like regulations, like, for example, the finance applications and healthcare applications, they need a lot of guidelines, and, they like previously the no-code providers were basically storing the data like metadata and all this kind of thing, and basically it was not allowing them to do it. But now even that has got, they found a problem with that also, because now all the storage is being internally managed with the cloud only. So many applications are launching even in the healthcare and, like a financial market with low code apps. So I'm sure, future, it will find more and more. So so the other links are okay. So there is this link provide you like a lot of if you are interested in the low code area. One of the biggest thing what low code solves is a UI part, and the UI part, this article is saying like React is a very big player in the UI environment. So basically this article provides a lot of applications that provide the no code development for the React. And this link is telling about, in case you are interested, you can explore it later. And the other one I came across interesting is something called Bit component design system. So basically what Bit is doing, you know about the Git, right? And where you are sharing the code and everybody is using it. So what they're doing is they are the same thing what Git is doing. The Bit is doing for the UI. So basically you can have your own UI, and then I can share. It's basically shareable components. And this article is telling about how can you develop a consistent and like a look and feel kind of app using the Bit design system. A UI, they call it as a UI component design system. And so it's a very nice read in case if you are interested more about it.
That is interesting, actually.
Yeah.
And
Most of
and other which is really catching up is called micro front end. So micro front end is something like so currently everybody is talking about microservices. So microservices, what is it is basically it's a part of a in a distributed system, and you have got you are splitting your big service into multiple services. So you got like an n number of services, and they do small things and they do that only. Okay, they do that the best way, but the challenge is like you have so many services now. You have like you have to orchestrate it, you have to, if there is anything happens, collaboration, all those kind of things. So same is being applied to the UI. Like for example, you have got a UI, and like it's like the front end is being served by different services. So you got one, you see one service that is being served by a service behind the scene. So if you want to change in this component or in this part of the UI, it is being managed, you want to change only that. So one problem, it's always, previously when we wanted to, change anything to the application, the deployment was, like, you need to bring the whole system, or, at least a full back end or front end, or sometimes both. But now it is like, all like, bits and pieces. That's why the DevOps is getting so popular, because, now you have got n number of microservices and micro front end, and all of them have their own like life cycle. Like they their own software development life cycle. They got their own build, cycle, CI/CD, everything is independent. And the advantage is that if you have a change in that, you are changing only that component, and and you are deploying it in an hour basis. You are doing it. So that is the advantage you are getting. So the micro front end technology also is being like bit is telling that they have a very good system for implementing that. So it's very interesting. I also came across it last week only, so I haven't explored much, but it seems very like a relevant for a enterprise development. So that's about the whole about the low code. And low code has got challenges. Like some of them have got an issue. So obviously, you have got if you want bigger customizations, you have got issues. And second is you once you launch your low code, you are logged to that vendor. You cannot like uh, go across the providers. You have the issues with that. And like there previously we had issues with like banking and healthcare had issues, but that also is getting overcome by the newer platforms. So they are finding now there are so many like banking applications running completely on top of the AWS. Previously it was not. That was one area where they were like hesitant to come to the cloud because of the clouds. But now AWS itself comes with they're like compliant like platforms. So they provide easier way to monitor and like what do you call it, regulated environments where you're auditing and all those kind. It is the provider only takes care of all those things. So overall it is a very promising area, and it will be nice to explore if you are interested in that. So that is pretty much I have. No code.
So they're very interesting session. So I think you did touch some very relevant points today of differentiating between the VM to container to using it as pay as you go. One question I had here is, one of the things as product managers we need to look at is various options, A/B testing generally in case of that. So it in that scenario, having a container based approach, would that be a best solution? What do you feel in that way? Like if I were to have an option A for an app MVP and option B for an app MVP, instead of pivoting the same thing, which approach then does look good in that way? Function based approach, or just going with certain containers?
Okay. So when you look into the containers or the VMs, you should see basically both are ways to give you the computing power. Okay, in terms of both of them have auto scaling, like you can scale like a VM, or you can scale container technology. Both you can do. But in terms of scalability, I would say the containers provides a little more, have got a little more advantage over there, instead of uh, auto scaling the virtual machines. Because they are the orchestration systems like Kubernetes, they are so advanced, like they provide much more advantage. And also much more, like in terms of like the security, all those kind of things, they provide much more. That is why like more and more companies are moving towards container technology, than like work sticking onto the VM scenario. So, but VMs are not going irrelevant, because behind the scene, like even the containers are running behind the scene, they are VMs, and there are scenarios where the virtual machines are significant. And the second point you told about, like A/B testing and all, they are actually like there are other systems, if you are talking about an enterprise system, like for example, in AWS, I can say there is a technology called app mesh. So I talked about like microservices. One challenge with microservices is that now uh, you have got the like like n number of microservices, which are, n means like there are hundreds, like even a company like Netflix, they are like thousands of microservices running. So you need a way where you want to manage the microservice. So for example, you are bringing a new change to a service, right? So you need a way where you want to basically when you launch the application, you, after all testing and all, you launch it and you want to do some A/B testing. And currently the providers are coming up with services like this. So for example, AppMesh, what it does is it provides help you when you deploy the service, a new version, right? It tells you like, okay, initially 10% only you go to this one, and then the 90% go to the old one. If everything is working fine, then you can automatically, you can, by changing a configuration, you can change the routing. Okay, so those kind of things are part of the cloud actually, and they are, I think they are separated. They are basically, they are about they are not, don't confuse it with the the VM or the container. VM or container is a plain computing, and and if you are thinking about about an MVP or a startup kind of thing, always think in terms of like a serverless, like Lambda, and like a container technology, which is serverless, which is Fargate kind of technology, where you have got less like lesser investment on before the hand. But like if you are thinking about an enterprise environment, like then you need to know more about what are the like keep learning about. Even I learned about the app mesh like a few weeks back only. So like it is the thing is that challenge is we need to keep upgrading ourselves. What are the new things coming up, and how can we make use of that? So if I talk about like I was in previous company where I was working, like we had around 50-60 microservices, and it is a really mess. If something happens and one of the service doesn't work, only way is again you go back to the old way of doing it. Like you write the logs and like analyze the logs and line by line. Sometimes we had to write it. And so if you have something like this, like the advantage of using the newer technologies, that like they provide you, like the tracking is easier, and second is they provide you inbuilt ways of doing things, like like doing the A/B testing, those kind of things. They are taking, basically they are listening to what challenges we are facing, right? Then they're providing solutions. And this app mesh kind of technology even can be run on the doesn't have to be on the cloud. You can run it on the non-cloud, in premises also, on premise also you can run it. So it's really exciting. Technology is moving really fast, and yeah, that is why like a lot of demand for the digital transformation. I hope I could I answered your question. Like I went from one end to the other end.
Yes, yes, yes. I think it did cover some other aspects of what we can as for the MVP or just putting out the app and putting out the function, checking it out. That definitely helps the
Uh, Sudhir, I have a question. So you were saying something about enterprise environment. Like, wanted to complete on that point. Like, do you think VMs are more preferable in when?
That is why, I think you don't have to worry about VMs or the containers. Okay, they are the two ways of like auto scaling. Auto scaling means like you have a functionality which you want to scale as on demand, right? So auto scaling can be implemented using VMs or using the
Sure,
containers.
sure. So there are no known concerns on terms of comparing the two.
Yeah, correct. The
Okay.
advantage of using the containers is there is a it is very structured way. You can the containers you can run on your local, and you can test them locally,
Right.
and you package them, and you upload, and then basically rest of the DevOps, typically in a company DevOps team takes care of it. That so the developers, the cycle ends typically when they test it locally and then upload it to the respective like registry. They upload their insert. Okay, and then so I think you don't have to worry too much about VM or container. Like both are uh, like both are powerful, but I would say like container technology is someone
Correct,
like
correct.
which
So
is.
I think one difference I see is that containers gives us more flexibility, because for VMs I need to predict and I need to keep them ready, right? But with containers, if I have a heavy demand, then probably that would stretch better in that scenario over VMs, right?
Yeah, containers are basically they have got more advantages than than
Correct, correct.
plain VM
Okay, okay.
auto scaling.
And Sudhir, I mean, if you don't mind, I joined a little late. I could not catch up with the first slide. I think I was 10 minutes late. Just
Okay.
to look at that slide.
Sure. So you mean like we are talking generally about
Okay.
how that evolved actually. So we started from the physical servers, and then where we had issues like we have to buy the service behind the hand, and then and there were and some of the in many cases like whatever we bought was not utilized properly. That is the biggest thing, right? That is a like a and also the cost of investment, right? To invest to start something new, right? So then came the technology called virtual machines. So it's a progression, like people found that okay, we don't have to buy so many machines. But you can buy a huge like a powerhouse of machines, which is the virtual machine host. Okay, and on top of it, you can run the n number, you can launch n number of virtual machines. So previously how it used to happen is like all the production machines will are running on like one virtual server, and top of it, as the demand comes, they launch more and more virtual machines. Okay,
Correct.
but then the problem was like virtual machines, many cases they didn't scale that well,
Expensive.
because took
Okay.
time to launch a new. It takes around 3 to 4 minutes to launch a new machine, because it's a complete new OS image, right?
Right.
Operating system. So that is why like needed more is faster scaling. So that is why the containers came in. So in the case of container, you have only one OS. Like typically all the containers are like Linux or like a Unix based containers. So even though there are Windows based servers and containers, but and then you have got one OS only, and on top of it, you are running the container. But you can have on top of it, you can run any kind of, like you can have a node application or ASP.NET application or different technologies,
Right.
because they are all packaged independently. That is the
Correct.
advantage of, and they can be within seconds. You can launch a new container, and like they can like they are horizontally scalable in this sense. So you don't have to worry about adding more and more power to it. And
Perfect.
then the third one is like came the functions is where you behind the scene you have got containers running, and on top of it you are writing only your function, what you want to execute. job, that job only you are doing. And, that job can be called in different ways. Like, for example, even, the services we write, services can call a function directly. So
Right.
it is only only a requirement of wiring that request to a function. Okay. So that is how we evolved. And, yeah.
So sorry, Sudhir, interrupting you. In the last case, can you give some real-time scenario which has got handled with this implementation?
Yeah. So this image we showed right here. So this what you see is called a Lambda in AWS. So
Right.
this is a function. Okay.
Right.
So this function, what it does is, when the user uploads an image to the bucket, okay, and that creates an event, and that event invokes this Lambda automatically.
Right.
What the event contains is telling, okay, I've got an image, and this is stored in this location in my bucket. Okay. And so this function, what it simply does is, okay, I have got an image. Okay. If I have a valid image, then, it basically calls this, like a container. Okay. It is actually like, you are calling, it is programmatically what it means, you are just calling like another module. You are just calling the.
Correct. It's like we are triggering a pipeline automatically.
Yeah.
In these
So inside you write the logic to invoke the container. So this is actually a function. Okay. And we call it a function, and the function can be implemented for a number of things. Only thing is, like there are limitations, like it can run like in AWS, it can run only 15 minutes. It's a max limit it can run. And obviously you don't want to run it for a long running durations, because, the cost is dependent on, like how much you run. It's charged per 100 milliseconds. So when you are running more, ultimately, you are paying up, ending up paying more, right? So,
I think also, yeah, and I think overall also it's good, because anything which is going to be a result of that function in output is also going to have an impact on the turnaround time. So I think that's why it's kept like that. Usually short.
So they are for short duration work. So if you want a long duration, then you go for the container, containerization.
Got it. Also, can we please have a look at the third slide? I think we were just looking at the.
This one?
Yeah, I think we looked at the third slide. So before this, yeah. And there was a second slide, I think, which I missed. I hope everyone is okay. I mean, I'm sorry, I'm walking through old content. If anybody has any queries, I mean, please go ahead. I can catch up on this a little later. It might take some time.
One question, Sudhir, what I see is this one, this no code, we can easily use it for our prototyping, instead of going to envision or creating stuffs.
Exactly. Yeah. So basically, like you can, even the product managers, even they can use it for a prototyping purpose, right? You just have to, behind the scene, you just have a sheet behind, and then you can very well express yourself. That is one area which is really like advantages. Then yeah, it's really good point. Yeah.
And another what Amar is telling, right? The MVP building thing. So for MVPs, instead of going to containers, we can simply use Docker images. So that would be faster and easily buildable. I mean, don't you think so?
So the thing is that, like when we talk about all these technologies, right, Docker and all, basically you are not going to implement it in your own level, right? Basically, you need to take care of, you need to implement it using some of the services, that AWS provide or the Azure provides, right? So you don't have to really know about the Docker or the Kubernetes, the orchestration, what is happening behind, right? See, only thing, what you have to do is, at the time of development, you need to develop in such a way that, the output is a image, right? Docker image, right?
No, for the MVPs or something, normally, because whenever we are going to AKs or any kind of other Kubernetes services, they are quite, they're not very pocket friendly, to be honest. So for MVPs, and we are not even bothered about scaling the thing, then we can use maybe a Docker Compose or a Docker thing, and then just get the Dockers deployed.
Correct.
And
Yeah. You can go for the Docker Compose, which is simple
the
solution
cost saving.
Correct.
Cost and the work saving, actually, rather.
Correct. Yeah, that you can do.
One quick question from my side, Sudhir. Not so much a question, more an industry observation. So until now, we've always, like until early last year or something, AWS has always been a leader in cloud. And then Azure has surpassed, like Microsoft has surpassed AWS. So from your point of view, what could have made them like what are they doing right to becoming like such a fast industry leader?
They basically want, but that is not really true actually, because Microsoft is really making big inroads now. Like you would have seen the last, in terms of, if you look at the revenue, right? They are really catching up with AWS. And AWS, advantage was they started. They are the beginners, right? And they started this. They came to the market in 2000. I think 2003 or 4. I think they were in the market. So yeah, so that is the advantage, and then obviously because of that, if you even if you take a look at the number of they provide all the possibilities. Like if you take the backend, they help us implement all kind of back, like Oracle SQL Server, or any kind of backend, and they provide their own, like for example MySQL and PostgreSQL, right? And to replace them, they came up with a DB called Aurora DB, and that is much more scalable than MySQL or PostgreSQL, and they are cheaper also. So they are bringing out a lot of inventions, because they started first, and then they are really aggressive in the market. But and then if you take a look at Azure, Azure has got pretty decent, compared, very comparable, but and how they are expanding is, like for example, I have a friend, like who was telling, they are giving huge discount for the startups, like first 3 months, like they are giving like 60% discount on the whole thing, So those kind of things, they are really making progress. And after, obviously, when you run 3 years for Azure, you are not going to move away to AWS, right? So,
Okay. But technology-wise, there isn't anything major different that Microsoft is doing.
No. It is basically very equal, and even all the three providers, they are very comparable. And Google is they provide they are not this much like options, but still it is ultimately it is same only. You have all these containers and storage, everything, all those things you have in Google also. Maybe you don't have the languages like like that many languages, like C# and all those things, but they have got a few languages, but AWS got everything, whatever you can think about in programming, they have got it. We have got it in AWS.
Okay, no, that's really helpful. Thanks, Steve.
Sure.
Anybody else? I think Sudhir is there on the group. One can reach out to him directly as well. But I think Sudhir, really helpful session today. It really gives us a good insight into technology and how we as PMs can leverage it to a large extent. So it really was helpful.
Sure.
Right.